Hi everyone, this is Kushal Himani, and today is day 7 of Arduino and Electronic Components course. Let's start. This is task 9, ultrasonic sensor interfacing. So we have already made this circuit in Tinkercad. Let's see how it works. This is the circuit that I've made. This is the code used by me. We'll be seeing this code soon. Now if we look at the sensor, I'll keep my hand here. It will tell us the distance. You can see my hand is 9 centimeters far from the sensor. This is how it will start working. Thank you. Now let's go to Tinkercad. Here it is. Go to circuit. This is the circuit that we have made. Tinker this. And we can use the other circuit for reference. This is the circuit that works. This is the code. We have to define the trigger pin and echo pin. So trigger pin will be 8 and echo pin will be 9. Let's just check. Trigger pin will be 8 and echo pin is 9. Let's go to code. Let's go to text. Delete the extra parts. int trig equal to it is equal to a. Yes. Copy this. Add the full stop. Full stop. This will be echo. And it will be equal to 9. It is best to use 8th and 9th pin because they transfer data fast. So there's one more thing about the ultrasonic sensor. It needs 1 second to adjust itself after the sensing. And it's the same thing with PIR sensor. So after the ultrasonic sensor is showing the distance, it will take 1 second to send the distance back. So speed of sound, if it is far, it will need some extra time to sense the how far you are. This is done. Next thing is trigger is for output, echo is input. Ultrasonic sensor senses sound reflections that I had explained. And the next thing is defining pins. Pin mode, trig pin is output. Let's type it. Pin mode in the bracket trig pin. So for us it is trig, comma output. In the brackets trig, comma output. All caps. And then bracket end, Arduino full stop. I just copy this, go here, press enter, control V, echo, and this can be input. You must be wondering why it is written in capital. Because there is a library If you write everything in capital, it will count it as a command. Otherwise, it will count it as a name. That is why names we don't capitalize things. Otherwise, it may interface with the library. Libraries are small in book of instructions. There are many libraries, 100, 1000 libraries. So in each library, there's a set of instructions which don't have to be written down. So you can just mention the library and it will start with the instructions and then it will use your code also. So the next thing is serial begin because of the serial monitor. Serial begin in the bracket, we have to write 9600 because that is the code we need. Let's check if it is blue. Yes, it is blue. Now we are done with the void setup, void loop. And this you have to create two variables, duration and distance. So we just put commas using a different variable using commas. Let's go back. int distance, comma, duration. The Arduino full stop. int distance duration. Now you are writing to the pin. Digital write trick pin low. So let's just write it. Digital write. It will be trick pin will be low. The next thing is trick pin is low because it will be off. And then after 2 microseconds, it will be on. And then after 10 microseconds, it will be off. Again, because we don't want it to send the signal continuously. Otherwise, if it sends continuously, the sensor receiving the signal will not be working. Delay, it will be delay in microseconds. So delay in microseconds. Delay, yes. Here it is. Now let's copy this. Enter, paste it in the next line. This we want to be high. Should be in all caps. Now we would want this again, but before that, in this line we have to add a delay of 10 microseconds. 10 microseconds so that after it is high, it doesn't stop at the same moment. So microseconds is very low, right? So it doesn't stop exactly after 2 microseconds so that it can sense the signal or it can let the signal go out of its system. Otherwise, it will be in the system and then you just cut the power. It will stop. So this is here. Next thing is duration. So duration we have to set in to pulse in because the reflection is a pulse. So suppose This is a sound wave. Sound wave is going and it is coming back. So when it touches the wall and comes back, it is a pulse. So it is pulse in. Duration equal to pulse in. Next line. Equal to its pulse ln. It's pulse in. Yeah, pulse in, not pulse ln. And then it is written as echo pin is equal to high. Echo pin, comma, high. Then the next thing is pulse is time taken. Here high is automatic. Measures when the echo pin is high. Duration gets stored. It waits for the sensing. And the next thing is distance duration. So let's see why this is here. We have Google, so let's search. This is found in the ultrasonic sensor tutorial. It is the speed of sound. Speed of sound is this. Senses from 4 to 400 centimeter. You have to change the speed to microseconds. And then it is divided by this. This times this divided by this. Equal to 0.034 centimeter slash millisecond. Centimeter per millisecond. And it is divided by 2. 2 is for two-way time. So because it has to go and then come back. This is two-way time. Go to the next slide. So this is what you have to write. Distance is equal to duration and it is multiplied by 0.034 divided by 2. So because duration is multiplied, it comes in a value. It is 1 centimeter, then it is multiplied. So this time is multiplied and then it is divided by this, divided by 2. And then the next, last thing is serial print. Serial.print. We have to print distance. So in the brackets, we'll write distance. The Arduino full stop. After we have written this, we need serial print ln and it should be centimeter. It will go to the next line and print centimeter first, and then it will print. First, it will print the distance. This distance it will calculate and then print the distance, and then it will print in the next line centimeter. And then just add a delay to be safe. And delay we keep 100. So this is the code. It's a small code, but if you add these points, it becomes large. So I will be sending you this code, this whole code in the description. Let's see if it works. It is not trig, it's trig output, and it should be trig pin, it should be trig normal, same here and here, and rest should be okay. Start the simulation again. Looks like the code has some errors. Let's see if this has any errors. Why does this have errors? Duration equal to pulse in. There should be something wrong. Or there is nothing wrong. Yeah, it should be echo, not echo pin. Let's start the simulation again. And it is working. Let's see what the value is. Serial monitor. It is 112 centimeter because it is 113 here. So there's some fluctuation, but that is okay. In the real sensor, there will not be any fluctuation because this is using a cheaper sensor or not the best quality sensor. There are some companies that make better quality, so they have tested one sensor and written the values. Let's stop the simulation. Let's go back to Tinkercad. And today I'll be teaching you one more extra thing. It will include the LED, the breadboard, and the battery. And we will not be using anything else. You may have thought that we will be using the Arduino, but no. So here it is. We will need a resistor. Let's take 4 resistors. I would like you to guess what I am going to make. No programming is needed. Let's rotate this. You guys can make with me, and then after that I will explain what I've made and you can guess. Same with the next LED. Why am I using so many LEDs without a breadboard? To be safe, we will be using a breadboard, but why am I connecting the LED to the resistor directly? It is because it should be portable. So if the circuit, you're sticking it on the wall, you can't stick your breadboard. It will be a waste of 300 rupees. So let's not use the breadboard here, but we'll use it uh, in the part where we are going to use the jumper wires. As I was saying that we'll be using the breadboard for connecting to the battery. Here it is. This will not be connected to anything. And then we need a wire which will be connected to nowhere. But that can't be done. So let's use the LED itself. Or uh, let's use a resistor because the resistors are waterproof. There it is. The resistor is connected there. We'll use one more resistor that can be connected here as a node. I hope you are able to guess. See, now these are connected to nothing. So we need a conductor or a wire. So instead of this wire, we'll be using water. So you must be thinking what this is for. So if you are filling a jug, you want to be notified when it is full or when it is at a half point or a quarter point or three-fourth. So this may be for 250 ml, this may be for 500 ml, this may be for 750 ml, and this may be for 1 liter. So water conducts electricity. Let's add the battery. A 9-volt battery. Negative will go to negative, positive will go to positive. Here it is. Now you will not be able to see if it is working in water or not because this is not a real circuit. So let's just connect it like this and let's start the simulation. You can see it is on. Let's delete this wire and see if it is off. Yes, it is off. So this is how it will work. There are many real world applications like if there is a well, the well has less water. So you want to see how much water is there. And you know where these wires are touching. So you can identify how much water is there. Let's switch back to the PPT now. This is all for this course. Thank you everyone for being here with me. If you have any questions, I am free to answer. I hope everyone liked the course, and if you have any doubts, you can ask me now. From the whole course, if you have any doubt, I will be able to answer. And I have also sent a poll. Please fill out that poll. Do you want any more live courses? Yes or no? Thank you all for being with me all these days. I will look forward to making more live courses. Does anyone have any doubts or queries? Romir Pratayush, Sheila, Malika, Ram, do you have any queries? Looks like no one has any doubts. Once again, I hoped everyone liked the course. See you in the next live course or the next video. Bye. Signing off. Thank you.